All right, so yeah, we're going to go 4 to the 4th equals 4 squared to the x power. And then all we need to worry about is the powers, because the bases are the same. So the base is the big number and the powers are the little number. So we'll say 4 equals 2x, and then we can just solve for x. Okay, so there's one way, x equals 2. Okay, now the other way is to do it 2 squared to the 4th equals 2 to the 4th to the x power. And then we've got 2 times 4 equals 4 times x. Okay. And then we just see, oh, we divide both sides by 4, 2 equals x. Okay, so we get the same thing. All right, page 3. Solve each equation for x. So we just need to solve for x. We've got 2 to the x plus 3 power equals 2 to the 2x power. All right, so what do we need to do to solve for x?
Minus the 3?
Yeah, we can minus the 3. Okay, so we're going to go x plus 3 equals 2x, right? We just need to look at the powers. That's all we need to worry about right now. Just the powers, because the base is the same. Okay, so x plus 3 equals 2x. Okay, so you think, oh yeah, I was going to look into that, Gavin, and I haven't had like very much time. Let me go up really quick, open in a new tab, blah, blah,
For
blah.
me, it says that we haven't done it, so.
Okay. All right, so let's go back to, oh, where was I? That's on this page. Okay, so we've got this one. And was it Felipe that said we could subtract 3 from both sides?
Yeah.
Okay, so we could go subtract 3, and now we have x equals 2x minus 3. Okay, what should we do now? We've got to get the x's together and by themselves.
Combine like terms?
Yep, combine like terms. So we've got an x here and an x here. We need to get them on the same side of the equal sign, right? Okay, let's do this. We're going to go minus 2x from both sides. X take away 2x is a negative x equals 2x minus 2x is 0. And then we've got our minus 3. So what does x equal? We need to,
3.
Yep, x equals 3. So we have to divide both sides by a -1, and then we'll get x equals 3. Okay. All right, page 4. Okay, this one, we don't have the same base. We've got 3 to the 5th equals 9 to the 2x power. So what do we need to do? How can we get the bases the same? Okay, one base is 3 and the other base is 9.
Is like what number do they have in common?
Yeah, what number do they have in common?
9.
Wouldn't it just be 3?
Yeah, they both have 3. So like 3 is 3 to the 1 power and 9 is 3 to the 2 power, or 3 squared. So we would go like that, 3 squared, and then put our 2x out here. So we still keep our 2x, this part right there. And then the 3 squared goes in the parentheses and it replaces that whole 9. Okay, so then we've got on this other side, we have 3 to the 5th power. So now our bases are the same. We've got a base 3 here and we have a base 3 here. As soon as we have our bases the same, we only have to worry about our powers. So we're going to worry about one side has a 5 and the other side has 2 times 2x, or we can say 4x. Okay, so 5 equals 4x. How can we solve for x?
Divide by 4.
Right, divide both sides by 4. 4 divided by 4 is 1. 5 divided by 4 is 4 goes into 5 once with 1 left over. 1 and 1/4 equals x. Okay. All right, page 5. All right, we've got 3 to the 2x plus 1 power equals 3 cubed. All right, our bases are the same. So that's great. Then we only have to worry about our powers. So I'll take the first power, 2x plus 1 equals 3. Okay, now we're ready to solve for x. What do I need to do first to solve for x?
Subtract the 1.
Yep, subtract a 1. So subtract 1, subtract 1. We'll have 2x on this side equals, and 3 take away 1 is 2. Okay, now what do I do?
Divide.
Yep, divide both sides by 2. And that is x equals 1. Okay. All right, page 6. Okay, page 6 says 8 to the 70th power equals 2 to the x power. Okay, what can we use for a base? We've got 8 and we have 2.
2.
2. Okay, so this side we'll just have 2x, and then 8 is 2 cubed. So in parentheses, I'll put 2 cubed. Oops, that's not a very good 3. There, that's better. Okay, so 2 cubed, because 2 times 2 is 4, 4 times 2 is 8. And then on the outside, I have the 70. Okay, now that we have our bases the same, got a 2 here and a 2 here, then we'll only have to worry about, oh, I forgot my equal sign. We'll only have to worry about the powers. So I'll take 3 times 70 equals x. All right, so what does x equal? What is 3 times 70?
210.
Yep, 210. So x equals 210. Okay, this next page is math notes, and we are just going to review some of the different methods for solving equations. The first one that we'll talk about is rewriting. Rewriting is where you use algebra to rewrite an equation. So one of these is where we distribute. So the distributive property is where you get rid of the parentheses. You're going to take this number outside of the parentheses, the 5, and you're going to distribute it to the things inside the parentheses. So we'll go 5 times x is 5x, and then 5 times -1 is -5, and then that's equal to 20. And then we're able to solve, we subtract, or we add 5 to both sides, and then we divide by 5. So that is the rewriting. Rewriting is where you use algebra to get rid of parentheses. All right, the next way to solve a variable or solve for a variable is looking inside. So looking inside is where we choose part of the problem, and especially if it's grouped in parentheses, and we say, oh, guess what? I know what that would equal. So if we look down at our example equation, they have 5 times x minus 1 equals 15. And we can think, okay, 5 times what equals 15? Well, 5 times 3 equals 15. That means this whole thing that's in the parentheses needs to equal 3. So we say x minus 1 equals 3. Then we add 1 to both sides and we get x equals 4. So that is the looking inside way of solving an equation. All right, the next way is undoing. So undoing is the thing that we do with the fraction busters, where we're undoing the fraction, we're getting rid of the fraction. Okay, so undoing is where we take an equation that looks really hard and we make it look easier. If we can think of it that way. All right, so we're going to look at this first one. We're going to say, oh, guess what? I can take this 5, and instead of multiplying it to everything, I'm just going to divide. I'm going to undo the multiplication, and I'm going to divide. If I divide on one side, I have to divide on the other side. So 5 divided by 5 is 1. That gets rid of it. And then 15 divided by 5 is 3. So then I'm left with my x minus 1 equals 3. I don't know why. Oh, there, now to let me highlight. And then we add 1 to both sides and we get x equals 4. Okay, so that's the rewriting, looking inside, and undoing. All right, let's go to page 8, and we're going to use different things. Okay, so we're looking at this wonky equation, it has 11x squared plus x squared equals 4x plus 8 times 3x minus 3. So which of those could we use to figure out what x equals? Rewriting, looking inside, or undoing?
Looking inside.
Looking inside? What do you think? If we look inside and we say 4x plus 8 times 3x minus 3 equals 11x squared. Is that going to help us?
Would it be rewriting?
What do you think? Rewriting. If we take 11x squared plus x squared and combine it, we rewrite it. And then we take the 4x plus 8 and multiply it by the 3x minus 3 and get rid of the parentheses. We rewrite it. Do you think that'll make it easier to solve?
Yeah.
Yeah, okay, let's try that. All right, so 11x squared plus x squared, that's 12x squared. And that equals, now we'll take 4x and we'll distribute it. We're going to go 4x times 3x. Here, let me write that down. I'll just go 4x plus 8 times 3x minus 3. Whew. Fit. That's amazing. Okay, so I'll take the 4x and go times 3x. Oops, I didn't click the red. Okay, 4x times 3x and then 4x times negative 3. 4x times 3x, that is 12x squared. And then 4x times negative 3 is a negative 12x. Now we'll take the 8 and we'll distribute it. So 8 times 3x is 24x. And 8 times negative 3 is negative 24. And then we can combine our like terms. We've got the negative 12x and the 24x. Negative 12x plus 24x, that's a positive 12x. So we'll have 12x minus 24. And then we've got our 12x squared right here. And that equals 12x squared. All right, now we're ready to solve our equation. I can subtract 12x squared from both sides to get rid of the 12x squared. And we'll have 0 equals 12x minus 24. Then I can say, oh, I am going to add 24 to both sides.
He was like, oh, that's for you for that computer to make that sound.
It is. That would be really bad. Okay, so 24 equals 12x. And now we'll just divide by 12. 24 divided by 12 is 2. So 2 equals x. Okay. X equals 2. And we used rewriting. So we multiplied to get rid of the parentheses. Is it snowing? Darn. Would be nice.
Yeah.
Okay. All right, page 9. Okay. We've got fractions. So do you guys remember what method we use when we're trying to work with fractions.
Isn't it undoing?
Yep, it's undoing. Because we're going to undo the fractions. I guess we could see it that way. Okay. So what we need to do is we need to come up with our common denominator. So we've got a 3 here and we've got a 9 here. What can we use for our common denominator?
9.
Yep, we can use 9. 3 times 3 is 9 and 9 times 1 is 9. Okay, so the first one, we see that it has a 3 on the bottom. So we need to just multiply the top by 3. The second one, we have a the second one, we have a 9 on the bottom, so we don't have to do anything with the x. We would like say we're multiplying it by 1, but you know, anyway. And then the third one, it doesn't have anything on the bottom, so we have to multiply the whole thing by 9. Okay, so the first one, x times 3 is 3x minus x times 1 is x equals 6 times 9 is 54. Okay, so then, and let's see, oh yeah, we said that that was undoing. Okay, so 3x minus x is 2x. 2x equals 54. What do we do now?
Divide?
Yep, we divide. So 54 divided by 2 is 27. Okay, so we'll say x equals 27. And then for explaining, we undid the fractions, fraction busters, whatever you want to say. Fraction busting. Boom, boom. Okay. All right, page 10. All right, so this one we're working with powers. Let's see what we can do here. We've got 6 to the x plus 9 power equals 36 to the x power. Okay, so what do we do here to solve this equation?
Would it be looking inside or
Yeah, it could be looking inside, right? Because we're looking inside these numbers to see how are they the same. And then we'll look inside the powers to solve for x. Okay. So 6 and 36, what will go into both 6 and 30? What can 6 and 36 both go into? This is that wonderful term from elementary school, the least common multiple. That used to make me cringe.
Is it 6?
Yeah.
Yeah, so 6 times 6 is 36, right? Okay, so we'll take our 6 and we'll say this one is x plus, can stay the same. And our next one, we're going to turn it into 6 squared, right? Because 6 times 6 is 36. And then we'll just have our x up here. So the x stays the same, but the inside turns into 6 squared. Okay. All right. Now all we need to do is worry about the powers. On one side, we've got x plus 9. And on the other side, we've got 2x. Okay. We need to combine like terms. So what should we do to combine like terms?
Subtract the x or subtract the 2x.
Yeah.
Yeah, either or.
Yeah.
Subtracting the x will be more useful though.
Yeah, so we'll subtract x from both sides. X take away x is 0, 2x take away x is x. And then we're left with x equals 9. So that's our answer, x equals 9. And then we said it was looking inside. And we could just say, looking at the, bases, looking at the powers, however you want to say. All right, page 11. Dang it. Okay, so this next one, we're going to do the same thing as we did in the other one with fractions. So we've got 4 over 9 plus 1 over a equals 2 over 3. And we'll just look at our denominators. Okay. So what do you think? We've got 4 over 9 plus 1 over a equals 2 over 3. And I'll give you a hint. Since it's a fraction, we're going to be doing undoing. We're going to be using undoing.
Would it be 3?
3 is one of them. So we're undoing the fractions, right? We're going to multiply the whole fraction by the same thing. So we've got a 9 here and an a and a 3. With our 9, we can also say that this is 3 times 3. And then our a, that's just an a. And then our 3, well, we've already got a 3 down here, so we don't need to write another 3. So what we can do is we can just times the whole thing by 9a. And then when we do that, that will get rid of all the fractions. We won't have any fractions that we're trying to add. Okay, so we look at this right here. We've got 4 over 9. We've got our 9, but we don't have an a, so we need to multiply that by a. The next one is 1 over a. It doesn't have a 9, so we need to multiply it by 9. And then the last one is 2 over 3. So remember, 9 is 3 times 3. So we've got 1 3, but we don't have another 3. So we need to multiply this by 3a. Now we're ready to rewrite our fractions. Okay, so we'll have 4a plus 1 times 9 is 9 equals And then 2 times 3a is 6a. And now we are ready to solve for a. Okay, so what's the first thing we should do?
Combine my
Subtract.
terms.
Yeah. So subtract 4a from both sides. So then we'll be left with 9 on the one side. 6a take away 4a is 2a. And then we just divide both sides by 2. 9 divided by 2 is 4 1/2. And then for our explanation, we can just say fraction busting or whatever you want to use, whatever you want to say to explain that. All right, page 12. All right, page 12 says the square root of x plus 3 equals 6. Okay, so whenever we're using a square root, like the first thought is panic. What am I doing with my life? But do you guys remember the Pythagorean theorem where you've got, oh my word, I cannot draw triangles. We're going to try this with there. Okay. All right. So we've got our right triangle. And this guy right here is the hypotenuse. And then we've got our 2 legs. One is A, one is B, and our hypotenuse is C. And remember, we've got to find out what C is, we go A squared plus B squared equals C squared. So this method is what we would use for solving for one of those. What we are going to do is we're going to look inside our square root and our equal, and we're going to kind of, what would you call it? I guess or rewrite it too. Like rewriting it also.
I mean, it's more undoing.
Undoing. Yeah, I think you're right. I think it is more undoing. We're undoing our square root.
Yeah, because by squaring, like they cancel out. So it's kinda
Right.
yeah.
Okay. So we're undoing our square root. When you take a square root and you square it, it gets rid of the square root. Then we're like happy with our lives. But remember, whatever we do to one side of the equal sign, we have to do to the other side. So we'll take x plus 3. We're going to square that square root. And then we will just be left with x plus 3.
Because rewriting would be more like if you write the square root as a parenthesis.
Oh,
yeah,
that's
that
right.
would be more-
Yeah, that's right.
Yeah.
Yeah, sometimes when I look at this, I'm like,
Yeah.
Look
it's so easy to
inside.
blur all of
what is,
them.
yeah.
I
I'm-
think Aaron had them like name them like whatever, like you want like a nickname before teaching them, like, oh, this is what we call them. And I think they're looking inside. David called it the supreme burrito method.
The supreme burrito method.
Yeah.
I like that.
Yeah.
That is, yeah, because you look inside your burrito. She's a genius.
Well, that was David.
Okay.
Still,
I can see that. Yeah, David, he's awesome.
Oh, baby.
Okay, so, and then I squared my 6, which is 36. Okay, now we're ready to solve. Okay, so all I have to do now is just subtract a 3 minus 3, and x equals 33. Okay, x equals 33. We could just say undo the square root by squaring, I guess. Okay. See, this is why we keep Ivan around, because he like knows all the good
I
stuff.
tried. Hey, anything else?
No, he said, take these back to you,
Okay.
because he didn't want them.
You don't want,
Semantic.
yeah, because they're not his, what would you want them?
Okay, page 13.
Okay. I remember that horse and drove by the dealer.
Okay, decimals. So with decimals, we can either multiply them all by 10, or we could just say, we're fine with decimals. Decimals are okay. So which do you guys want to do? Do you want to multiply everything by 10? Or do you want to just leave it how it is and figure it out that way?
Multiply everything by 10.
Multiply everything by 10? Okay. All right, so the first one, 1.2 times 10 will be 12. So that's 12m minus 0.2 times 10 is 2 equals 3.8 times 10 is 38 plus m times 10 is 10m. All right. Okay, so that's kind of, what would we call that? Rewriting, I guess, because we're just rewriting everything without the decimals. Okay, so now we're ready to combine like terms. Let's see, let's start by combining the m's. We've got a 12m on one side and a 10m on the other side. Since the 10 is smaller, I'm going to subtract 10 from both sides. So minus 10m. 12 minus 10 is 2. Okay, now I'm ready to work with the 2 and the 8. So negative 2 and a positive 8. I'm going to add 2 to both sides. So plus 2. 38 plus 2 is 40. Okay, and now we're ready to solve for m. So we divide both sides by 2, and m equals 20. Okay. Okay, and rewriting, we could say multiply by 2 or by 10 to get rid of the decimal. Okay. Okay, I think we might have time to go through 2 more problems. Let's see. Maybe we'll just do 1 more. And then we'll start on review preview on Wednesday, tomorrow. Okay. All right. So page, oops, I went one too many. Page 14. We've got x plus 12 quantity squared equals 9. Okay. This one, it's kind of, it's okay. x plus 12 quantity squared equals 9. Okay. So 9, what is something squared that would equal 9?
3.
3.
Yeah, 3. So we can rewrite our 9 and say that is actually 3 squared. And then we've got x plus 12 squared equals 3 squared. Now all we have to worry about is our bases. So our base on one side is x plus 12. And our base on the other side is 3. Okay, so now we can solve for x. All right, we've got to get x by itself. So I'm going to subtract 12 from both sides. 3 take away 12 is 9. And then I've got my x. So x equals 9. Oh, negative 9. Forgot my negative. Don't forget the negatives. That's so important. Okay, so let's see. We could call that looking inside because we were looking inside the parentheses, I guess. And we were looking inside the 9 to say, hey, 9 would be what squared? What do you think? Would it be looking inside or rewriting? I think it could be either of those.
Looking for factors of 9.
Yeah, looking inside. Okay, so looking inside parentheses and looking inside the 9.
Yeah, so like, if they, like, what plus 12 equals 3.
Okay. All right. Okay, so we will just stop there because next we've just got review preview. So we'll start on review preview tomorrow. And you guys did great. And I dropped my
Hey everyone. See everyone.
Now I'm muted. Okay. See you guys tomorrow. Have a great
Yeah.
rest of your Tuesday.
Hey.
I know. Hey, that's a good skill. Okay. Bye, guys. Thanks for coming. I appreciate all you guys do. You're awesome.